All right, let's take a look at Unit 5, Lesson 2, Moving Functions. So we're taking a look at vertical and horizontal translations using our function notation today. So 2.1, what happened to the equation? We're going to graph each function using technology. I've got my Desmos graphing calculator out here. Describe how to transform f of x equals x squared times x minus 2 to get the functions shown here in terms of both the graph and the equation. All right, so let's take a look at the graphs. And I'm going to first put in the first equation, f of x or y equals x squared times the quantity of x minus 2. So our original is our red graph. And then we're going to take a look at our h function, which actually I'm going to put it into function notation. So we'll do h of x equals x squared times the quantity of x minus 2, and then outside the parentheses we have minus 5. So take a look at what happened, excuse me, to our original function here. What looks like it happened, it has been translated down 5 units. So we'll go here. I'm going to use green so it matches. So I'm not sure what's going on here. I want that translated. There we go. So it's been translated down 5 units. So that's the graph. The graph has been translated down 5 units. If we're looking at the equation, then your outputs are 5 units less. So like we have the point 0, 0 here, and then we have the point 0, negative 5. So your y value is 5 units less, and your y value is your output. So if we're looking at the equation, the output is 5 units less. So now let's take a look at our g of x function. So we're going to do, I don't know why it skips one there. That's weird. And actually, I probably could have just done that without tapping that plus, but that's okay. So that equals x minus 4 quantity squared, and then times x minus 6. Now this one might be this one might be a little harder to see with the equation, but with the graph, I think it makes it a little bit easier. So let's take a look at this one. So we're going from the point 0, 0 to 0, or I'm sorry, 4, 0. We also, that looks like the point 2, 0, and that moves to 7, 0. So if we look, it's been translated 4 units left. I'm sorry, right. 4 units to the right. Okay, but now if we take a look at our output is 4 units more. Okay, now keep in mind, so when we looked at our vertical translation, we could take that at face value. So our negative 5 meant we were going down, right? Negative means down. But here in number 2, we have, I'll use orange for that. We're subtracting 4, right? Our original was x squared times x minus 2. So if we plug in x minus 4 for that, we have x minus 4 squared and then x minus 4 minus 2. So we just replaced all the x's with a minus 4. And so then that simplifies to x minus 4 quantity squared times the x minus 6. And that's how they got that. But keep in mind that when you're adding or subtracting the x value, you have to think opposite. So when you're subtracting 4 from the x value, you're actually moving to the right, which is positive. If we were to add 4 to the x value, we'd be moving to the left, which is the negative direction. So when you're putting it in for x, when it's a horizontal translation, you have to kind of think backwards. All right, so let's take a look at the next piece. We are looking at these two graphs, and I'm going to go ahead and get rid of these. We will use the calculator. The graph of G is a vertical translation of the graph of F. All right, so this is our function G, and that's this one here. So this one is the vertical translation. This one is the new graph. And then our graph of polynomial F is this one. All right, so we're going from the orange to the blue. That can get kind of confusing sometimes. All right, so we're going to complete the G column of the table. All right, so that's down here in number 4. So when x is -4, we can see that y is +4. When x is -3, that looks like -1.8. When x is 0, -0.7, it looks like we're at 4. And then when x is 1.2, it looks like we're at 0.7. All right, and so we have 0.7, and then for 2, we have that point up there, so that's 4. Okay. So we've completed the table. F of 0 equals -0.86. That's right here when you plug in 0. So that's like this point right here on that y-axis. What is G of 0? And that's going to be right here on the y-axis. So G of 0 is going to be, and what do we notice is the pattern here? We have a vertical translation. How is it moving? Well, if you notice, all of these are adding 4 from the f of x to the g of x. So we're adding 4 there. So it's going to be -0.86 plus 4. So G of 0 is going, that's a 0, not an O, is going to be, what would that be? 3.14 would be our G value. And you can look here, and that is a little bit above 3. So, all right, so we're going to write an equation for G of x in terms of f of x for any input. So G of x is equal to, remember we took our f of x value and we added 4. So G of x is just taking our f of x function and adding 4 to it. All right, the function h can be written in terms of f as h of x equals f of x minus 2.5 or 2.5. So complete the h of x column in the table. All right, so basically what we're doing here is we are taking each of these values and plugging them in here to get our h of x. So 0 minus 2.5 is negative 2.5. Negative 5.8 minus 2.5 is negative 8.3. And then this one's going to be negative 2.5 again. Negative 3.3, negative minus 2.5 is going to be negative 5.8. And then negative 2.5 again. All right, and then we are going to sketch the graph of h. So we've got, let's see, -4, negative 2.5. Let's make that a little bit smaller so we can see the whole thing. -4, negative 2.5, so that's going to be right about there. -3, negative 8.3. It's going to be right about there. Negative 0.7. Negative 2.5, it's going to be somewhere around there. 1.2, negative 5.8, it's going to be right about there. And then 2, negative 2.5 will be right about there. All right. So now we're going to try to connect these. Oh, that is ugly. Let me try that again. That's a little better. All right, I don't expect you to be perfect in your drawings. It's fine, as long as they look pretty close. And then we're going to write an equation for g of x in terms of h of x. So g of x, remember that g of x was equal to f of x plus 4, right? And h of x was equal to f of x minus 2.5. All right, so if we want to write g of x in terms of h of x, what we can do is we can get f of x by itself over here, and then plug in our f of x for in the g function. So if I add the 2.5, then I know that f of x equals h of x plus 2.5. So now I can take this piece and plug it in for f of x here by using substitution. So g of x is equal to h of x plus 2.5 plus 4, so that's going to be 6.5. And that is g of x in terms of h of x. All right, let's take a look at heating the kitchen. Okay, so a bakery kitchen has a thermostat set to 65 degrees Fahrenheit. Starting at 5 a.m., the temperature in the kitchen rises to 85 degrees Fahrenheit when the ovens and other kitchen equipment are turned on to bake the daily breads and pastries. The ovens are turned off at 10 a.m. when the baking finishes. Sketch a graph of function h that gives the temperature in the kitchen h of x in degrees Fahrenheit x hours after midnight. So we're starting at 65 degrees, and then starting at 5 o'clock, the temperature in the kitchen rises to 85 degrees Fahrenheit. Then at 10 o'clock, it gets turned off, and then it goes back down. And so it's going to come back down. Let's say it takes an hour to come back down. All right, so actually, we'll say it starts rising at 5 o'clock. So then it'll take an hour. And it says sketch a graph. So it doesn't give us that information, but we're just going to add a few more details there. So at 5 o'clock, it starts rising to 85. It stays at 85 until 10 o'clock, and then it's going to come back down, and we're going to say it takes an hour for that to happen, and then it will continue to stay at 65 degrees for the rest of the day. Okay, so that is what the graph could look like if it takes an hour for it to go from 65 to 85. That information wasn't actually given to us in the problem, and that's why it says sketch a graph, not the graph, because there are a couple of ways you could have done this. All right, so the bakery owner decides to change the shop hours to start and end 2 hours earlier. So again, we're starting at 65 degrees. This means the baking schedule will also start and end 2 hours earlier. So instead of going at 5 o'clock, it's going to go at 3 o'clock. And then at 4 o'clock, it'll be at its maximum of 85 degrees. And then it'll go until 8 o'clock, and then it will come back down. So at 3 o'clock in the morning, it'll rise up to 85 degrees, and then it will stay that way for 4 hours, and then it'll come back down, and then it will stay at 65 degrees for the rest of the day. Again, we don't know how long it takes for the temperature to go from 65 to 85. We just made it easier by making it take an hour. All right, so explain what h of 10.25 equals 80 means in this situation. So h was the original function. So that was our green function. 10.25 would be like right here, and that equals 80. So that means at 10:15, because that's a quarter of an hour. So this is at 10:15, because a quarter of an hour is 15 minutes. The temperature is 80 degrees. And that is reasonable because the temperature is going back down from 85 to 65. All right. If h of 10.25 is equal to 80, then what would the corresponding point on the graph of G be? And so again, we're looking here, and it would be, I didn't draw that line very well, but so it would be G of 8.25, because remember the whole graph shifted to the left 2, so we're subtracting 2 from that time so that we can get our correct time. And so that's going to equal 80 degrees. So at 8:15, the temperature will be 80 degrees. So if we're looking at writing G of H G of, what was our variable? X, in terms of H. So G of X. All right, so what did we do with this X value to get this X value, right? So if this is X, G of X, then this one has to be X plus 2. So that's going to equal H of X plus 2, because we added 2 to our X value to get the H function. All right, and then you can take a look at the summary if you want to read a little bit more about vertical and horizontal translations.